In the previous video, we have seen how to classify, quantify, and map the different waste produced in an healthcare facility. In this video, you will learn about the different stages of medical waste management. Since there is no universal answer, we will also discuss how to choose between systems and identify good and bad practices. Medical waste management can be divided in 5 main stages. The first stage is the segregation. The sorting of the waste in established categories must always be the responsibility of the person who actually produced the waste. Usually, it's a clinical staff member. Ideally, as soon as the waste is produced, it has to be disposed. It must be done as close as possible to the site where the waste is produced. And of course, it's worthy to mention that if the waste is separated, it means that the treatment will be different. There is no point in sorting waste that eventually undergoes the same treatment process. The second stage is the temporary storage. Waste must be collected regularly. It must never be allowed to accumulate where it's produced, to overflow. The volume, the capacity of the containers, and the frequency of collection are the main parameters to account. The third stage is the transport. The waste are separated in categories and transported to the waste area in a way that reduces the possibility of accidents, like spillages, for example. Finally, in the waste area, we deal with the treatment. According to the system in place, there is a treatment to reduce the volume or make the waste not dangerous anymore. Such treatment should be the responsibility of the hospital and done on site. Finally, the disposal, the final and definitive step. Usually it consists in burying it in a sanitary landfill or in a dedicated waste pit. Here, an example of a plan with a specific solution for each category and each stage. Note that the general waste is not included because if it's not mixed with infectious one, it doesn't pose any risk. The one presented here are solutions typically encountered in low-income settings. But how do you come up with such a plan? Well, that's indeed the tricky part. National legislation, when existing, must lead the way. When a legislation is not available, resources exist to support the decision-making process. Here, you can see a decisional tree proposed by the ICRC. Here, other examples of same scenarios proposed by the WHO. This one illustrates an urban area with access to modern treatment facilities. This one, an urban area without access to treatment facility. And this applies to a peri-urban location. And finally, a rural one. You can later go through each of them in details. What is common to all these scenarios is the existence or not of national regulation, the availability of treatment facilities, the space availability, the proximity of neighboring communities, and the existing of financial and human resources. The specific steps in the process might vary, but remember that the objective is always the same: safely reduce the risk of infection spreading. So, finally, in concrete, how does a system of medical waste management look like? How do you do if you have to get rid of sharp objects like needles, scalpel, or broken glass? Here, one example, one system, again, that can be appropriated in low-income settings. We need to start with the segregation. The simplest option might be to use only a safety box. It's a paper carton box, widely available everywhere in the world, that is specifically designed and labeled to transport sharp waste. Sharp boxes need to be transported into the waste area. They can be incinerated and finally the ashes and the remaining needle disposed into a sharp pit. The operations behind each step need to be correctly performed. Hospital staff need to be properly equipped and trained. For example, segregation requires to strictly separate the different categories. If this is not done, the consequence is very simple. All the steps down the line cannot work anymore. You can see 2 examples, one of a bad triage and another of a well-organized nurse trolley with the proper medical containers ready for segregation immediately after the generation of the waste. Same applies for all other steps. Here you see a bad example of storage, while there a good one. Let me stress what is the point here. The first picture is an example of bad practice, but not because it shows an environment dirty and not well kept, but because it does not accomplish the principle of reducing the risk for the users of the health facility. Those boxes left unattended are a temptation for the kids, for example. They can easily spill over its content and therefore requiring remediation procedures which are just extra risk that is added. Again, guess in which picture it is easier to have an accidental spillover of the sharp box. Sometimes very simple and low-cost solution like a trolley with a flat bed and security railings on the sides can have a huge impact in reduction of accidents. No need to be always fancy. Once again, same question. Which practice in the picture do you think entails less risk? We have finally arrived in the waste area, a space that needs to be controlled and properly equipped. Clearly, there are some practices that are not recommended, and they can be extremely dangerous for the operators and the surrounding community. Slow burning, for example, that is shown here, is extremely unsafe. It's a dangerous exposure to dioxins. Maybe at this point, it's important to distinguish between burning and incineration. Burning is a thermal oxidation of waste able to produce a reduction of the volume, but not its decontamination. Only when incineration conditions are reached, we can talk about destruction of the pathogen load in the waste. Oxygen, airflow, temperature, and retention time, they should be in the right mix to allow incineration to happen. I'd like to stress a point here that often come up. Medical waste management is often assimilated with incineration only. Sometimes building or providing a new incinerator is seen as a kind of miracle solution that makes all the waste problem disappear. Unfortunately, an incinerator is only a step of a whole system. And actually, incineration should be limited as much as possible because it always comes with important negative effects. A comprehensive study on small-scale incinerators commissioned by the WHO in 2004 proved the following conclusion. Single-chamber incinerators, what I often call pizza oven, should be banned because their emission level is not acceptable. They don't reach incineration conditions. Double-chamber self-combustion incinerators, like this one, should be used only as a transitional solution. If chosen, the way they are operated is paramount. It can tilt the balance between the overall cost-benefit analysis. The same machine can give very different results. More advanced technologies, such as assisted combustion double-chamber incinerators, or completely different technologies like a small autoclaving, for example, should be promoted as soon as the proper condition of financial and technical sustainability exist. Problem is that in many cases, these conditions are very, very difficult to meet. But once again, they should be evaluated on a case-by-case basis. Here, a table summarizing the suitability treatment techniques by type of waste. So, now it's clear. There is no standard solution. Here, once again, I show you another example to treat the same category of waste sharp. In this case, segregation is pushed further. Within the same sharp category, we now differentiate between needles, glass, and scalpel. Each of them has its own dedicated container that is directly disposed with a dedicated device on top of the pit in the waste area, where the sharp will be permanently disposed. This provides multiple benefits. It reduces the manipulation of sharp inside the waste area. It reduces the accidents due to glass explosions. It reduces the amount of waste to be incinerated. And all of these are very good points, but they need to be counterbalanced by more attention required by the staff, more follow-up to ensure that the segregation is properly done. And this is always a weak point in all systems. Once again, no miracle solution, always depending on the context. Protecting public health through the management of waste can be achieved by a variety of methods. A context-specific analysis should guide the selection of an appropriate system. A way to assess the overall proposal or a single change in the system is provided by this reverted pyramid, the waste hierarchy, illustrating the most desirable method at the top to the least desirable at the base. Let's see some concrete example of application of these principles. Prevent. For example, many medical equipments, such as intravenous bags, artery catheters, blood bags, dialysis bags, contain polyvinyl chloride, PVC plastic. Incinerated, they produce chlorinated dioxins, which are extremely potent toxic substances. Alternative products, PVC-free, exist in the market. Their choice would prevent a major problem. Another example. The use of digital X-ray imagery would totally prevent the problem of disposal of toxic development liquid. Let's make an example of the reduce principle. The strict respect of segregation procedure can dramatically reduce the quantity of waste to be handled. Not everything is infectious. There is no need to treat kitchen waste as a dangerous waste. And this, unfortunately, is not always the case. And finally, let's make an example for reuse. This is a reusable sharp container that has been developed by Médecins Sans Frontières. It is safe in protecting the medical operator from accidental puncture, and it can even be built locally with local material, and it prevents during his operation, this for example shows how to discharge into a pipe in the safe pit, its content. So it's really something that can be reused, diminish the quantity of material, and it's safe. So what's the point here? Try to use these principles as guidelines when designing a waste management system. Keep in mind that at the same time, more often than not, you will need to compromise in order to enforce sustainability or to reduce cost, but always choose the option that is reducing the overall risk. In conclusion, to recapitulate this video, we briefly saw the actual steps of a waste system. We saw how the overall system should be designed according to the local resources available. And more importantly, how each step should be properly executed in order to obtain the desired effect. Finally, we review the overall set of principles that should be always at the basis of a sound medical waste management system. For more information, I invite you to refer to this text. Here, the World Health Organization Blue Book on Medical Waste. Here, the technical guidelines produced by Médecins Sans Frontières with a very practical approach. And finally, here in the French version, the guideline used by the International Committee of the Red Cross.